The operating principle of the driver's and passenger side airbags are identical. The complete airbag module, housed in the center of the steering wheel or in the passenger side of the dash, consists of gas generator, airbag, and a padded cover with predetermined rip seam. The modules are triggered by a control unit which detects the rapid deceleration of the vehicle during a collision. On single airbag systems, other than the S14 and J30 models, the control unit is in the steering wheel. In contrast, on models fitted with twin airbags and in the single airbag systems of the S14 and J30 models, the control unit is positioned in the passenger compartment, somewhere along the vehicle's centerline. Internally, the control units differ depending upon the model and age, but basically they all include a microprocessor and two deceleration sensors, one electronic, known as the G sensor, and the other mechanical. The G sensor, often of the piezo crystal type, generates a voltage when the rapid deceleration of the vehicle is detected. The mechanical sensor, usually of the reed switch type, is referred to as the safing sensor. In the event of a collision, due to inertia, a spring-loaded magnet moves forward. The magnetic field, now surrounding the switch, causes the contacts to close. Only when the signals from the G sensor and the safing sensor simultaneously agree, and the microprocessor recognizes that the deceleration is caused by a frontal collision, is a voltage signal sent to trigger the gas generator in the airbag module or modules. The generator contains a substance described as a solid propellant. The triggering voltage from the control unit ignites a priming charge, which in turn burns off the solid propellant. This substance produces nitrogen gas to inflate the airbag. The bag inflates within a few milliseconds to cushion the occupant as he or she is propelled forward by the impact. The bag then immediately deflates at a controlled rate to allow forward vision. The total time taken between the vehicle first making contact in a frontal impact and the airbag finally deflating is about 85 milliseconds. If the vehicle is fitted with twin airbags, then the passenger side bag is triggered 10 milliseconds later. This is because the distance between the passenger and the airbag is greater than that on the driver's side. If both bags were triggered simultaneously, the passenger's airbag would have deflated before the occupant's head had made contact with the bag. To ensure that the airbag is activated even in the event of the control unit's power supply cables becoming severed during a collision, the control unit includes a reserve power supply in the form of several large capacitors. The airbag or bags are deployed only in the event of a frontal collision within a maximum range of 30 degrees to the center line of the vehicle and at road speeds above 12 miles per hour. This fact, and the fact that the two sensors within the control unit have to simultaneously agree, prevents erroneous triggering of the system in the case of minor accidents or extreme driving conditions. On twin airbag systems, the bags are of different sizes. The driver's has a volume of 70 litres, while the passenger's is 130 litres. Due to the larger capacity, some modules use two gas generators to inflate the passenger airbag. Driver's airbag-only models, which have the control unit inside the steering wheel, have a bag of 40 litres in capacity. The reduction in size is due to the space occupied by the control unit. To ensure maximum reliability, the electrical connection between the steering column and the airbag module is made by a spiral cable. On some models, the cable also provides the connection for the buttons of the horn and cruise control if fitted. Unlike the dragging contact of a conventional horn mechanism, the spiral cable provides a permanent connection, irrespective of the steering wheel's movement. To detect electrical problems within the system, the airbag control unit contains a diagnostic circuit. If the system is without faults, the warning light should illuminate whenever the ignition is switched on and go out after about 7 seconds. A flashing or permanently lit warning light indicates a defect, the cause of which must be investigated immediately. The efficiency of the inertia reel seatbelt is considerably increased by the pre-tensioner. By tensioning the seatbelt during an accident, it removes any slack and thus restrains the occupants more effectively. In a frontal collision at a road speed in excess of 12 miles per hour, the pre-tensioner tightens the belt against the body within 24 milliseconds. Seatbelt pre-tensioners can essentially be divided into two categories: mechanically controlled and electrically controlled. The electrical type, as fitted to the QX for example, include a cylinder, a piston and a gas generator. A steel cable connects the piston to the reel of the seatbelt retractor. The firing element of the gas generator is connected by an electrical cable to the airbag control unit, enabling the airbags and the seatbelt pre-tensioners to be triggered simultaneously. When the generator ignites, nitrogen is released. The expanding gas forces the piston up the cylinder, causing the cable to reel in the seatbelt by up to 120 millimeters. In principle, the mechanical pre-tensioner works in a similar way. The main difference is the method in which the gas generator is triggered. Instead of an electrical signal, an integral mechanical G-sensor is used to ignite the explosive charge. It consists of a permanent magnet and a ring magnet so arranged that their poles oppose each other. In the event of a hard frontal collision, the inertia or G-force acting on the permanent magnet overcomes the opposing magnetic fields. The magnet moves forward and contacts the needle's flange. This pushes the needle forward to strike the percussion cap and ignite the charge. The force acts on the piston, which travels upwards and tightens the belt. To aid safe removal and installation of the unit from the vehicle, a safety lever is provided. It acts as a temporary locking device for the G-sensor. The advantage of the mechanical pre-tensioner over the electrical version is that this type of seatbelt can be installed in vehicles which don't have airbags.